Thanks, everybody. This is an unusual event. At least I'm hosting with this group for the first time. I have done a few of these sessions with other groups within Bloomberg, and it's actually very interesting. Just because you learn how to basically, get the discussion going. The fun part for me was when I do these events, it's usually at a nice restaurant in the city, and it involves some nice food and wine, but we'll save that for next year. So let me start with some housekeeping items. I think today's topic is something that is near and dear to a lot of us. COVID-19, again, it's really, I'm repeating myself so many times sometimes when I'm talking to people. I've never seen this level of digital disruption across anything that I've covered. Now, let me start off with, my name is Anurag, and I cover the software and the services space at Bloomberg Intelligence. So Bloomberg Intelligence is Bloomberg's in-house research arm, and my job at Bloomberg is to write research on both companies and the tech industry, and we write our research on the terminal for our customers to read. And I cover most large cap technology companies that fall into this area, which includes IBM, Microsoft, Oracle, SAP, Salesforce, Workday, Shopify. So, from my side, a lot of these companies are right in the middle of a lot of these digital disruptions. We just published a very big report on this topic that touches on digital payments, digital commerce, cloud-based software, security software, networking equipment. And the whole point is we have not seen, any acceleration like this perhaps since, Y2K. And the reason I'm very keen on learning from all of you is to understand really what's happening in the, industrial landscape as well as the supply chain world. So let me just do some housekeeping items because this is more about the virtual event we have. If you're having trouble with audio or video, please refresh your browser. If Bissell crashes or you get disconnected, please refresh your browser and log back in. You may see my video box currently blocking the slide behind me. You can click on it and move my video box to a different part of the screen. Now I'd like all of you to take this time. If you have other web applications open, please close them. That should help with the bandwidth. And again, one of the things I like to do about a lot of these sessions is keep it extremely conversational. Just to figure out what people are thinking, what are some of the areas that you're focused on. For me, learning from all of you, we write about every major emerging technology topic out there, 5G, blockchain, and you name it. But it's really a lot of people like you who are implementing these technologies. They know the reality from all the hype. And that's really what we really want to discuss today is where are we really in terms of the development of some of these technologies. I was just at Costco the other day and I was looking at the screen and the software over there was just probably from 25, 30 years ago. And I asked them when was this developed? And I don't think they had any idea. They said, I know I've been working here for 10 years. It's the same software. So the realities of some of these stores are so different than what we hear and read about it. And I would love to hear, everybody's thoughts on some of those topics. I also really want to, thank our sponsor, IBM, for making this virtual roundtable possible today. Before we start, I'd like to introduce David Meek, partner for IBM Global Services, who'll say a few words for us.
Hi, Anurag. Thanks. Hello and good morning. My name is David Meek, and I lead IBM's Global Manufacturing and Industry 4.0 practice. IBM itself has been a manufacturer for over 100 years, and much of our expertise and our solutions come from our own factory value chain. I'm excited to talk about how IBM is helping companies improve their bottom lines, and a lot of that comes from applying artificial intelligence at the edge. And as all of you know, in manufacturing, everything happens at the edge. And the advance of AI and the inferencing of models at the edge really improves manufacturing performance for many of our clients. And I'd like to share an example from one of my clients. It's an auto parts supplier. They're currently using 7 different AI models to monitor and predict weld quality at each of their welding stations. They're using visual insights to count spot welds and assess if each weld looks good. They're using infrared cameras to see the heat penetration, so critical for welds. They're also using a microphone and acoustic insight models to listen to the welding, and our production optimization machine learning algorithms to detect anomalies in the welder operation and predict the final quality of each weld using the PLC data along with outputs of the other AI models. Now, today, instead of taking a chassis off the line and destroying it to assess their general weld quality, they're now assessing the quality of each individual weld. And with over 300 welds on a chassis alone, this has enabled their double-digit cost reduction in their overall quality. While this is great, and where many companies fail, is how do they scale these AI models across their thousands of work centers? And they've got plants on several continents all over the world. So what's neat about this is, there's new edge enabling technologies like Red Hat's OpenShift that allows manufacturers to deploy these edge solutions either on premise or in any cloud. And in my experience, most global manufacturers have different clouds, a lot of times dictated by their geography. IBM's Edge Application Manager also allows companies to manage AI at scale. And this is especially important if you're using high bandwidth AI models like computer vision, which deals often with high res images, and being able to inference at or near the camera can remove and lower the latency challenges. And now we have the imminent arrival of 5G that's going to enable both the collection of data and the deployment of AI models and add a lot of flexibility to the plant floor. So as manufacturers are adjusting to the new normal brought on by COVID-19, I'm looking forward to hearing from my fellow panelists today on how they're tackling all of this. Thank you.
Oh, thanks, David. So let's kick it off and talk a little bit about, just the edge itself. I mean, we wrote a piece about this a couple of years ago. We were, discussing what it can do to different industries, including industrials and consumer and transportation. But frankly speaking, without really 5G kicking in, where are we in this topic? In a sense that in your adoption curve, have you started to use a lot of this work, or are you still in the planning phases, or where exactly are some of the bottlenecks for you? So we'll just open it up and see if anybody has any thoughts on that.
Maybe Anurag, this is Raja. I can maybe give a quick insight. So if you look at edge computing and cloud computing, when initially this thing started in manufacturing, everybody rushed to cloud computing. That was like the in thing to do. And so they were trying to get into cloud, but they quickly realized that cloud is expensive. It costs money to upload, costs money to download. The other is, as the technology progressed, you started getting video analytics. When you have video analytics and images and videos, those files cannot be compressed. And then, as David said, this goes back into latency. And so as they started to enter into cloud, very quickly as technology progressed and larger amounts of data were being needed to be processed, they started to look at, hey, maybe that's not the best thing. And so they started to fall back a little bit to edge computing. And edge computing is also there, but it has its own risks. So I think at this point, I would say it's like a hybrid model. People that require very low latency because of data size, or if there are cybersecurity or risk issues, they go to the edge or on-premise. And those that have very high compute requirements basically go to cloud. So I think there's a hybrid model that's emerging right now.
Mm-hmm.
Say, Raja, that's very impressive. I just want to give you an example. We recently did the upgrade to the GPS systems kind of worldwide, all the ground stations. So think tens of millions of lines of software. So architecturally, we have to separate the cloud from millions of lines of software, but also then we have to control the satellites and handle things in milliseconds. So a lot of times the cloud is determined by what you're doing, the architecture, and where is it reasonable to do functions. And that's changing dramatically with the advancement of microprocessors. And we're shifting back to so much processing being able to be done at the edge. It's changing architectures. Mm-hmm. So how you think about a cloud, how you think about what's being done, and the transfer, how much time it takes to grab that information. We just put this constellation up. We had about 2,000 software engineers in Aurora working on it. But in the end, GPS is ubiquitous for everybody from finance to defense. You got to be careful how you set up your architecture, not to dead end the discussions on microprocessor technology because everybody's competing for that. And secondly, that your architecture sets up for timing. As Raja said, 5G will get you down to milliseconds, but milliseconds is used for a certain precious amount of bandwidth. And it's got to be for things like positioning satellites or, moving sliced network data between the kid in the back seat downloading movies versus safety in a car where you've got to make sure that you can pretense an airbag because somebody might hit you. So that kind of architectural changes are happening a lot in automotive, commercial, defense. And I find it fascinating right now to look at sort of computer science 101 has almost changed as we think about the architecture and decisions. Yeah. And I think the winners or losers will be who makes those architectural decisions correctly.
And if I could add on to that, at Bobcat, we just implemented an AI vision inspection system, and we started in the cloud. And because of the data requirements and the other things, we actually started now using edge computing to be able to handle all that visual data and images that are coming in. But the other comment I was going to make is all these systems now are a lot easier to pilot and experiment with. We were able to stand up a pilot on this in about 3 weeks. 5 years ago, you never could have done that quickly. And so you had to make commitments early. I think because the technology is really easily being able to be experimented with has really helped us as a manufacturer anyway to at least sample these different technologies. And now we selected one that we're using for visual inspections, and we're going to roll it out in other plants.
Just one other question on that, or comment on that as well. Joel, you mentioned being able to iterate. And I think that's where we all are. We start with one model and then we iterate. And, just as David mentioned with the company, doing the weld inspection. So we're in the transportation. We're using all of those technologies, edge computing, robotics, automation, cloud AR, especially, we focused it in our engine facility for locomotives. Where do you want to get the biggest benefit, just like the other company did on their weld? But it's an iteration. It's not like you're done. You continue to evolve. You continue to look at the best technology and make sure that you're getting the benefits from it. So these virtual reality tools are becoming more and more accessible with 5G and with the bandwidth, whereas before you couldn't even dream of, using virtual reality to design, products, to train your field service team. So I definitely think it's an evolving technology that we're all seeing benefits as we increase the bandwidth.
Yeah, I think that's right. And if I can just build on that, Alicia, I think the modern solution has got to be a hybrid one between the cloud, on-premise solutions, and edge, right? And we certainly do that as a contract manufacturer. We've got thousands of pieces of equipment where we've got edge computing to do data capture and process improvement, which we can then take into create a learning database where we can apply AI onto that and use that to learn things about millions of different custom CAD files that we generate over time to help improve the outcomes, improve productivity, and refine our solutions to be more customer centric. We couldn't do that all in the cloud. And then also for security reasons, we have to be very thoughtful about, with ITAR and our customers' data, we have to be very thoughtful. So, what we maintain on premise, what we can put in the cloud, and what we want to do at the edge to be able to have these outcomes. It's all really relevant.
Great. We have another somebody raised hand. Matthias, you have raised your hand.
Yeah. No, I just want to tie on what you say here as well, speaking for Ericsson then. I mean, I think for many years, of course, we've been working with data to solve problems, right? And solving the traditional problems inside manufacturing. Technology now will take us to basically expand the number of use cases you can put to solve through, edge compute or through data. At the same time, we can move away a little bit from the traditional OT system or the ERP systems and that are extremely process tied, and extract and put the data at one location or easily accessible location. And then you can work across different sites and reach basically scale, even though you're running multiple smaller units as we do, being as close to customer as we can. you can still cross-feed the data, learn from each other, and instantly apply the learnings directly to the production processes. Additionally, I think speaking for myself from the other side of my company, providing 5G, we're all looking for this silver bullet, the magic use case. Speaking for operation side, I don't think there is one, right? The key is that when you add and stack the 50 and the 100 and the 200 use cases or microservices or whatever you call them, that's when you build and stack the values extracted through data. With 5G and all these tools and buses coming now, it will basically expand that you can put more on a stack and actually motivate to take the investment. That's an important piece for us to show that works as well.
You had something, Anne?
Yeah, I wanted to build on all of those comments, great comments, and I'm coming from the consumer industry side. Certainly, as Alicia said, we continue to iterate, and I think that includes finding new use cases every day. And in our case, our holy grail, if you will, is to drive end-to-end supply chain transparency. So what we want to do is we use all the same applications, but we want connectivity across all of them. We want one system to speak to another. So we have full visibility of what's going on. And a really important application that we have accelerated during this past several months during the pandemic is we were already on a path to integrate fully point of sale data. Because, as we're an essential products company, Colgate Palmolive, so we saw these huge surges in demand. We were concerned that at some point with all the pantry loading, that would drop off. So the point of sale data was very critical for us to make sure that we understood how to manage our inventories and our production. So tying that all the way back to our planning systems has been really critical. And one final comment in terms of challenges, especially with the cloud. Robert brought it up, but is the security piece. That's a huge concern for us.
Yeah, hi. Thank you, Anne. Tamara, you had a point too?
Yeah, everybody, we're in the same spot across when it comes to manufacturing. What the major difference for us is the chance to really test out. Because just like what Matthias said, you have to have this technology stack. And you can't show the value just on one piece. It's really about the stack and understanding the pain points to be able to drive it to the next level. So we've been doing some testing with 5G as well, and we see the benefits, huge benefits. Instead of in a factory having drops that are $1,200 each, right? Now it's real-time data where you need it at the right time. And it's a completely different viewpoint than Wi-Fi. And so getting people to understand the opportunities, the biggest challenge is really upskilling, right? Changing the skill set of our teams through the manufacturing plant to see the possibilities. So thanks for this opportunity.
No, that's good. Go ahead.
One thing that hasn't been brought up is the concept of model-based engineering and digital thread as we go through our manufacturing facilities. We're trying to grab, 60, 70,000 engineers and manufacturing of jet engines to, radars. So we're really putting a push in to make sure that, the data coming through and the digital thread all the way through the manufacturing, kits, engineering design changes, and then at the end, digital twins so that we don't spend so much money selling something off, whatever it is. It doesn't really matter what product. It's very difficult at the end to throw a big switch that says, oh, it works, take it. Compliance, selling it off with reliability data. So at the end of the day, the digital transformation and what is manufacturing, but also design engineering, we can't let the engineering teams get so far ahead because we're doing such great things with low latency 5G, with a lot of cool technologies, machine learning. At the end of the day, these data sets may lead us in a non-deterministic way. We may end up with the wrong answer. Just because we have a lot of data and we have a bunch of neural networks grinding through it doesn't mean we're going to end up with something that makes sense, right? So there's a little bit of data integrity, and then we want to make sure we end up with the right products. If you add that into additive manufacturing and composites, the world really changed. how we build things, how fast we can do them, and all this is crushing into us right now. And where you put those resources to spend on those different kinds of technologies is going to be who makes the best bets at the end. So it's made 2 cents.
No, that's fair. Just one point. If you're not speaking, could you please put yourself on mute? I think sometimes there is slight, backdrop coming in. But Raja has, raised his hands. Go ahead, Raja.
Yeah, really quick point. Really good points that everybody brought out. One thing about edge computing is it's an asset. And when it's an asset, that means you own it and you have to maintain it. So it has its benefit, but then as you start adding these assets, you need to look at who's going to maintain these equipment. And that becomes a big issue. And also, do they have, as Tamara mentioned, do they have the skill set to maintain these systems? Some of these skilled trades that have been in the industry are not familiar with these edge computing devices. So I think asset management becomes a big problem as well. So.
Robert?
So,
Robert,
excuse me.
Oh.
Yeah, thank you. I wanted to build on Mark's comments about advanced manufacturing and digital thread. That's a topic that's a great passion of ours at Protolabs. We're a contract manufacturer. We were founded 20 years ago, really with this vision of digitizing the manufacturing process. And so we've tried a lot of things in this space to basically take internet and software technologies and blend them with the physical manufacturing process. And what we really found is that it takes a real combination and portfolio of technologies of all kinds in order to really do this effectively. But when you do it right, it can take a lot of time and cost out of the manufacturing processes, and thereby enable agility in the supply chain in ways that we couldn't have before. And I think you did a great job of summarizing a number of them. Digital twins, how you use the cloud, AI and the analytics around it, industrial Internet of Things, like all of these together, along with the edge computing, can provide tremendous agility. And we've seen that, recently with the disruption around COVID. We had the opportunity to make 8 million parts in the last several months in a matter of days with response times for our customers, and things like face shields, ventilators, test kits, all because of how we've created agility within our manufacturing process to be able to meet those needs at a time of significant demand volatility. So I think this is it's an exciting time to be in manufacturing right now.
Oh yeah, exciting time for anybody who's involved in anything technology related, frankly. Bissell, you had you had a comment?
I was just going to add that, our world at Aerion is very different from your guys. I can resonate with a lot of what you say, mainly because of I spent 35 years running a large aerospace company before I transferred over to a startup company. But as a startup company, it's a very different perspective. You don't have a lot of legacy infrastructure that bogs you down. You don't have all the issues that come along with trying to make change and the high cost associated with making change when you have all your platforms already established. But coming up with what to do in the future. So, where we are in our current startup of our company is in the advanced design part of the aircraft. And so when we talk about digital twin and the digital thread, we're establishing those components as we build out the architecture over the life cycle of the program. We're in the phase of the program right now where we're, in the middle of trying to meet what's called PDR, which is, our initial design review. But through all of that iteration of the aircraft, OML, and the MDAO capabilities, we did most of that HPC computing up in the cloud, and it got quite expensive. It was critical from a schedule standpoint because we were able to do very intensive computing, more so than what we were capable of doing in our own HPC environment and a colo, but it came with an extreme amount of cost. And then as COVID-19 kind of hit the environment and changed the, I'll call it the financial markets for us as a startup company, that's relatively important. We had to switch back to mainly our on-premise system and actually try to increase the computing capabilities of it. When it comes to things like the edge, clearly that'll be part of our architecture as we move towards building out the manufacturing environment. We'll have a lot of high automation in manufacturing, especially around some of the components that we're going to be manufacturing ourselves, like the wings of the aircraft. But in our partner environment, right now we have an integrated PLM with many of our large partners, from Boeing to Spirit to Aeronova to Fulker. So we're international with our partner strategy. They're part of our design partnership, moving forward. And we've had to put together an architecture that allows them to collaborate on a design, I think the biggest challenges, believe it or not, that we've had on that isn't so much the application and tying people in, as much as every company's unique InfoSec capabilities have really bogged us down. From Boeing to General Electric to Spirit, they all have their own unique environments that has created a very large difficulty in collaborating. I would just say this: we're in a very different position. We're building out our architecture, taking the knowledge of our team from many different large aerospace companies where we all came from. And we're trying to do it in such a fashion that we are not establishing large data centers, and we're basically going into the cloud as much as we can, and colos for mainly our on-premise capability.
No, that's good. So Alicia has a point, and after that, I'll move on to the second question.
Yeah, I just think this is pretty interesting with what Bissell brought up, and also Ann and a few of the team members. If you think about moving to the cloud, and you think about how we used to, engineer and even forecast our services and aftermarket, right? When you start building that digital thread, you don't have to do it the old-fashioned way. You're starting to do the predictive maintenance and how you actually stock and have your really anticipate what your work scopes are going to be and develop repairs, no matter if what industrial components it's for. You can start doing that before you even see the parts, back on your docks. And that's one of the things we've done that in the aircraft industry in my previous roles, and also we're doing that in our locomotive engines. With that predictive maintenance, with the digital twin, it's really taken a lot of cost and cycle time, out and guesswork. We used to have to forecast all of this, build all the inventory, not use it, and then really have the part come in with a different issue. So that whole digital twin extends beyond, our new manufacturing, really into the service industry as well, which we haven't spoke about much here. But it all comes back, into a full circle of you have to design that in and think about that when in your manufacturing process, if you're also responsible for the aftermarket, support of your product as well.
No, that's fair. One of the common things I heard from almost all of you right now is, the discussion about cloud. And, we have been discussing this for over a decade, even longer, about AWS and what's happening in public cloud market versus private cloud. But we have been a big proponent of hybrid and the importance of on-premise system for a very long period of time. And I'm just curious as you look to the future, going out several years, do you expect more than 20% or 25%? Like, how do you expect? Because we still feel that for a lot of companies that have been in business for a while, they would love to keep, their independence and their openness, and then not be locked in with one particular hyperscale cloud provider. But I'm just curious because, on one hand, I talked to, let's say, somebody in the financial services industry said, we don't care, we're moving everything to the public cloud. And on the other hand, I do talk to some people that said, we want to take full control and we're going to run with everything internally. Where is the audience in between now as you talk to your CIOs and your executive teams? Where do you think going out next, 5 years or even 10 years, where do you think that ratio, ends up for a lot of you? And you want to start off, please?
I think for us, we're looking at about a 5-year journey, and we're really looking at it from the standpoint when you look at cloud computing costs. They were on about a 74%, downward slope on an annual basis, and now is kind of flattened out at about 50%, but it's still not far enough that you can use it a lot and get so the value really comes right now from the computational capabilities that you can get out of it. But again, our intent is to be 60+% in the cloud when we stand up an ERP, and we'll stand up SAP. We plan on doing it completely in the cloud. The only complexity that we get into is around classified environments and some of the military work we'll end up doing with our first AS2 aircraft. And so we still are trying to work through that, but the intent is to not be standing up data centers and infrastructure and really offload that to, I'll call it third-party providers, because we just think it's a much better value and we can focus on the things that we really want to do instead of just standing up lots of teams to do the infrastructure work. It's not really where our, core competency is. We're starting with a very low and small team. So we see that a lot, but we're going to judge it over time based on the value, and we expect the prices to drop quite a bit.
So Rana,
you had a point?
Yeah. So I'm not sure I could put an exact percent on it, but we, like Bissell, we're definitely moving toward the cloud in an upward trajectory. We run on SAP as our enterprise system, and we are actually, ironically, this week starting our first wave to move everything to what they call S/4HANA, which is a cloud-based SAP operation. So, in fact, we were one of the first companies to use SAP starting back in early 90s. So we have a longstanding relationship with them. I think just like Bissell mentioned, though, we have on the one hand this move in that trajectory in that direction, for sure. I would say, if I had to put a number on it, definitely greater than 50%, but with a hypersensitivity on the cybersecurity side. I mean, that's always been very, very huge focus for us at the same time.
I wanted to say something about cybersecurity. The Air Force has sponsored classified clouds and so on. But when you think about cybersecurity, there's data at rest in the cloud and there's data at rest in your products. It's when data moves that you have a big problem with cybersecurity along the way and how you handle packets and so on. Yeah. But for the most part, a lot of times edge computing is sitting in your products. So every one of your products typically has microprocessors or FPGAs, and there's control systems in there, and there's data crunching in there. So at the end of the day, you have to be very careful that you don't allow the cloud to be in the loop on anything you deliver. Whether it's your supply chain, whether it's diagnostics, or whether you're doing some remote operation and you put some kind of a vehicle on Mars or something. I don't know. But at the end of the day, latency is everything. That's why 5G is so important. But also integrity of what you're doing. But yeah, even the classified environments can be done. Cybersecurity will be everything from connected aircraft to how you think about air traffic control systems and how you think about whether someone can take the time to hack into a maintenance microprocessor and all of a sudden control your maintenance. So I think it will rule the day on how you think about the stack.
No, fair. David, perhaps I could get you to address a couple of things I heard here. One was around cybersecurity. The other one was about openness and the whole cost aspect of it. You probably deal with,
we deal with it every day, Anurag. One of the important things, a lot of the modern solutions aren't just in the cloud or just on the edge. And a great example are the computer vision type solutions. So you take a bunch of images, you send it to the cloud, you use a lot of resources to quickly tune and create an AI model that's detecting quality, for example, in an assembly. And then you send that back to an iPhone, an intelligent camera, and it can inference right there at the edge. So we're seeing a mix and a kind of a what I call a for-purpose use of the different nodes in the overall stack and architecture. So that's one thing that I'm seeing. And so you're using the cloud for what the cloud is good at. You're using the edge for what the edge is good at. And then the other aspect of your question really comes in the general openness. And I see this as a change for a lot of companies selecting and using cloud providers. You know, it was just a few years ago, companies were making a strategic choice, not unlike choosing an enterprise system like ERP. All right, we need to pick a cloud provider, and that's our permanent choice. And what's happened is they have one for SAP, they have one for Workday, they're using a different one for Salesforce. And so most companies of any size are often using multiple clouds. And that's what I see more and more companies deploying their applications with Red Hat OpenShift. They can deploy it on-prem using their own hardware and keep it secure or isolated. They can deploy it. We have a client in Europe who's an auto manufacturer who's deploying it in Europe on AWS, and they have 50 plants in China, and they're deploying it on Alibaba in China. Yet it's the same software and solution stack.
We have a bunch of people who want to comment on this. Raja, let's start with you on that.
Sure. So I think from Denso, there's no question that we are cloud-first strategy, even though, as I said, edge computing is mainly driven by latency issues, as Mark mentioned, and cybersecurity. But what is happening is the data in motion encryption technology is rapidly improving. And so this concern of cybersecurity reduces because now you have tremendous encryption algorithms during data in motion. And so then when that goes away, the only other thing left is latency issue that prevents you from going to the cloud. And what is known as fog computing. So fog computing is starting to really enter the space. And that is where shallow computing is done at the edge, but very deep computing continues to be in cloud. So I think cloud first strategy is something that you're going to see from all the companies go there. It is just really important. And as far as cybersecurity for IP issues, what companies are doing is they're standing up private cloud. So which means, for example, IBM has Bluemix, right, David? And you would then have Bluemix set up a specific cloud environment just for us, for Denso, for example. So yet it's in cloud, but yet it is a private cloud. And I think that is a solution as we continue to go towards cloud. So cloud first strategy is definitely where the industry is going.
Fair. Tamara, you had a point as well?
Yeah, so we've been on the cloud for years. And really what it comes down to is, and we expect that to continue to grow with time. What it comes down to is really we're going to have, just like everybody else said, multiple different ways to approach this. Because on the shop floor, what matters is a supervisor, a manufacturing engineer, a quality engineer getting the right data at the right time with different means to do it. But we want that seamless to them to put them in the right spot to be proactive on some of these key issues. So you'll see us continue to use the cloud and look for other alternatives. We've also done some testing with 5G as well.
Okay. Joel?
Yeah, I think at Bobcat, we've taken a little bit of a hybrid approach where it made sense for us to roll out things for cloud. And for instance, we just put telematics standard on all of our equipment. So we have 100,000 connected assets in the field. And obviously that made sense to go in the cloud. But now when we're doing big data analytics and we want to analyze that data, maybe with our manufacturing data or warranty data, we actually left that in the current systems. And we're just using some different ways to pull that information in, because we just found it didn't make sense to make all of that investment right now to move those systems into cloud today. But we're still able to leverage it. And so I think we've been a little more opportunistic, or maybe a hybrid approach in how we convert and look at our data going forward. Just when it makes sense for us business-wise, we'll do the conversion, but only when it does.
Fair enough. Matthias, you had a point? Matthias?
Can you hear me? Are we
Yeah,
good?
we can.
Very
Good.
All right. Now, but if we leave the cloud security part, let that rest for 1 second and talk about the new challenges that comes on my table here then, right? I mean, in the past, the access to information or data has been restricted to a certain logon to a certain system somewhere, traditionally, right? Now we unlock a lot of data. I do a lot of data plumbing, as we call it, and put that into data lakes, independent of the system where it may come from or the process where it might come from in the manufacturing. So now I need to think about who should have the right to read this data, who should have access to this data. At one hand, we have the traditional process engineers or the manufacturing engineers. They are trying to, through the process knowledge, capture data that they can use to solve their problem. But now, at the other hand, we have the data analysts, the data people that can, through just, harvesting the data, crunching the data, they will see to which problems we can solve with data. And when you marry these two together, that's where you create the magic sauce a little bit, right? That's where you can solve new problems or solve problems in different ways. Now, if you assume that data is the key of that, you want to open up the data for everybody. Right? You want to have people to play around with the data, to seek solutions from the data, even how we can mix with customer data, with supplier data. So at the very start, when we design our new data lakes, I need to think about, being an operations guy, and classify the data. What kind of uses do I may have in the future? How do I build rooms with external data and match them with our data? And usually I've been protected throughout a lot of years through IT departments and other departments. I think about this very much myself, because I want to enable as well, right? I don't just want to restrict. So that's a new challenge for all of us, I think.
No.
Anyone recognize this, or is this only me sitting with this problem?
No, fair point.
Unleashing the potentials.
No, fair point. I think integration is a very big issue for most software companies, and they're focusing very strongly on that. Robert, you had a point as well?
Yeah, thank you. I wanted to really build on what Matthias just said, as well as Tamara. I think that one of the things that's really crucial around this is making sure that as we want to empower the shop floor, we want to empower leaders at all levels with the right data in hand. We can spend a lot of time thinking about the systems and the data and the architectures and so forth, but I think a really critical element is creating the right culture of continuous improvement and making sure that you've got that structure for empowering leaders at all levels to make use of the decisions from, and take ownership of those decisions based on the data that they have. I think that, there are some things that you can take the data and you can automate them completely. And that's definitely easier. But, what we found is that those tend not to be the highest value applications of edge computing or of analytics. The highest value ones, at least for us, seem to be those where you involve and empower the people, at the site, at the edge, to make the right decisions. And so I think a real foundation of that is having the right culture, structure, and employee development in place, which then allows them to capitalize on it. I think if you just start with the systems, you won't be as successful. At least that's what we found. I'd love to hear if others have, have that same kind of experience.
Your thoughts, Alicia, on this?
Yeah, I was smiling to myself with Bissell when he was commenting about how he's not inhibited by, the legacy platforms of previous companies. My current company, we have over 31 ERPs, and this is really our future. Is we're going to continue to do acquisitions, divestitures, and have all this background. So 20, 30 years ago, it used to be our initiative was get everyone on the same ERP. Now it is all analytics and data lake and cloud computing. How do you get that data? And, as Matthias and Rob were saying, make the best decision with it. It may not be perfect. You may not have all the data. You may have 80%, and that may be good enough to make the right business decision. So I do think it's about the skills, the mindset, the training of how do we use the data we have to make the best decisions without looking for perfection, because we'll never get there. And really, it's a mindset change of what you need to go after, because you can still get tremendous benefits running your operation this way and making decisions this way, where you can do those type of high level, analysis. So I look at it from a supply chain operations standpoint. It's the only way I can run my business today is off of the data in the, aggregated data in the data lake.
No, fair. Tamara, go ahead, please.
Yep. Yeah, so some great points from the team and from John Deere. When we look back through, we've been really doing this concept called lab to lighthouse. And it's really about, the advanced manufacturing, identifying opportunities, but having a couple lighthouse factories where those pain points are really identified right on the shop floor and then linked to the lab. And that's where we're seeing the synergies really take it to the next level. And without that, when we went through COVID, I'm so proud of the team in terms of we haven't been impacted on quality or safety. Our safety actually improved. And there's all these tools that were developed deeper in the organization to understand absenteeism, move MEs and QEs, manufacturing engineers, quality engineers to the right spot at the right time. And all of that's being developed on the ground level to ensure success. And so, again, going back to that lab to lighthouse connection point is really what's been a differentiator for us on the manufacturing side as well.
Okay. Anne?
Yeah, so I love the conversation around the culture, as Rob was saying, and the importance of people. It's not purely about the systems, the data, and the technology. And I hear it from everybody here. And what's been, and we've been on a journey to change the mindset, to really push decision-making down to empower people. That's been a huge focus for us. And side by side, looking at how, the data and the insights available can help people to do that. What's really been vindicating is during COVID, again, operating as an essential goods company, we saw it in action. We surprised ourselves, so to speak, because we actually saw we didn't have time to allow decisions to flow up. People had to take decisions quickly and use the information at hand. And we did things like, streamline our portfolio by 30%, down to 30%, just so we could operate. And you can't do that without that access to that kind of information and data and analytics. So it was extremely vindicating. And I've been trying to find a way to work my sweet spot into here, my passion, which is sustainability. I'm now the Chief Sustainability Officer of Colgate. And I guess the way I could work it in here is that the fact that we had access to so much data, so we could focus is the other key here. Being able to focus and make decisions allowed us to keep our sustainability program going full speed ahead. In some cases, even accelerate our programs around, environmental kind of efficiencies, whether it's energy or water reduction. We have not missed a beat. And I don't think we could have done that without, the suite of tools that we've had.
Fair enough. I just want to, talk about one particular thing, just because, when we started this question, we were looking at, private and public cloud and the importance of that. I also want to, focus on one topic that I've heard a number of times people talk about here, is the supply chain itself. Even before COVID happened, there was a lot of discussion about how to change the supply chain of manufacturing companies, industrial companies, because of the tariff war or, the over dependence on China. As you think about it again, going forward, looking at, in the future, how people dealt with COVID or dealing with COVID is good. And, but I would love to hear a little bit more about what you guys are thinking about how you're going to change the supply chain going forward, so that you're able to fulfill orders, fulfill your customer requirement without overly dependent on one region, one geography. Just to give you an example, just bought some appliances they won't show up here till the end of September because they haven't been shipped from South Korea yet, and they're going to be stuck on several areas. So, I mean, this is becoming a very, very big deal across the globe because there are massive bottlenecks right now. So I'm really looking forward to learning from all of you as to where are the investments going in supply chain that will completely change the way you operate.
So if I can start, Anurag, it's a really good question on supply chain. So if you look at Denso, it's a global company. So we have operations literally on every continent. And you hit spot on about the supply chain having bottlenecks. And I'll give you an example of a technology that we're using that can permeate into our supply chain without adding a lot of upfront cost. So CapEx is very low. So what we have done is we have products coming from Vietnam, Thailand, India. And as you said, there are bottlenecks. And so what we've done is we've employed wireless sensor technology. So if you look at the old technology, which is RFID, it's very CapEx intense. And it's also very difficult to push down to supply chain because it costs a lot of money. So this wireless technology or IoT sensor, smart sensor, actually monitors intermodal. So it doesn't really matter whether your product is coming from the plane or the ship or the train. It provides a continuous real-time data and visibility of where your product is until it reaches it. And not only that, it provides an ETA when it's going to arrive. It is so amazing that we had a shipment out of Vietnam and the supplier was actually telling us something else. And we did a trial with this wireless sensor. And it actually was telling us information of physically where it was on the plane, even more accurately than what the supplier could tell us. And the cost of implementing such kind of technologies are becoming so affordable that I think wireless sensor technology is the way to go from a supply chain standpoint. That's just one example.
No, that's a great one. And just to give you a sense, we are 6-7 minutes away. So I would love for everybody to participate in this question, and I also would love for David to give his insights as to what he's seeing in other customers. So if you won't mind just keeping it a bit short for the next few minutes, that would be very helpful. I'm going to move on to Matthias. Please go ahead.
Version where I think we have learned a lot from COVID, right? We as a company, we also deliver technology to our customers through our products. So we have production facilities close to our customers in each continent. Here, there's a price to that. It's smaller units and they are distributed. Technology comes into where automation enable us to establish ourselves in also high-cost countries because it's less dependent of salaries as such on a high automation degree. The data and the connectivity where we connect everything that can be connected, that's how we can reach scale across facilities as a big scale production. So that's how we use technology to establish ourselves, and it does make perfect sense also with the business that we do. The smart factory in the US, our investment we did put in operations here during the first quarter is one example of that, where we have a new factory here built in the US.
Okay. Robert?
Yeah, thank you. So I think, one of the biggest challenges that the world is facing right now has come from the disruption that COVID has created. And I think it's really served as a wake-up call for businesses to embrace digital transformation in manufacturing right now. I think the need for, agile supply chains and how to respond globally to this is absolutely, at the forefront. And, we have a digital thread that runs through our entire operation from request for quote through to shipping and then subsequent, customer outcomes. And that, along with the other technologies that we've talked about and some of our kind of secret sauce, allow us to make parts, in a day in custom parts across a broad range of technologies so that we can really be an on-demand partner for our customers. And I think these disruptions that we're seeing, the macro trends have been true for many years, right? Shortening of product life cycles, SKU proliferation, localization, a number of these things, demand volatility. But what's happened is COVID has really amplified these trends and highlighted the impact and the need for agility in the supply chain. And so I think it's absolutely right. That's the big challenge right now.
Fair enough. Joel?
Yeah, in our manufacturing operations, we actually took a little different approach. We've done some things to simplify things for manufacturing, build less configurations at our factories, and we rolled out features on demand this year. And so we're able to push that more closer to the dealer and the customer, where they can custom configure their machines the way they would like them, closer to where they are. And that frees up our manufacturing to build more standardized types of products. And COVID helped, well, I shouldn't say help, but it accelerated that development along the way for us to look at our business in that way.
Yeah. Alicia, please.
Yeah, we spoke a lot about, the battles you have to even get your material into your supply chain and then transform it. The other part on the other end is you're ready to ship your product. We have large industrial products, and then your customers are accustomed. It's actually a requirement that they come in and they sign off on the product. That's typical with large industrial equipment. So we had the other issue where we had product piled up and customers unable to travel into our sites. And this is global, all of our locations. So we had to very quickly change our terms and conditions, work with our customers to do video acceptance. So it was really not just within our supply chain, but even extending out to our customers. And then we had the similar situation with COVID-19 on field service. We were used to shipping the best person over to handle this. Well, we can't. We have to use the person in country, put the Google glasses on, train them up from the expert. Yeah. So just some other, representations of the supply chain doesn't stop when you finish making your product. You still need to get it accepted to get your accounts receivable, and then you still need to service it or put it in service within the customer's facility as well.
No, that's fair. David, let me bounce it off to you, just because we have a couple of minutes left only. I really want to understand, just in the topic of supply chain, what are some of your major customers doing, to basically make sure this bottleneck never happens again in the future?
Yeah, I'm seeing a lot of changes, obviously, in the source and being able to move from anywhere from 2 or 3 vendors to a dozen or more vendors. But probably the best example is from our own supply chain. We have global plants, and in our mainframe, for example, it might take over 30,000 different individual electronics pieces before we have a finished product out the door. And like many of the companies have stated, we have all sorts of tracking of inbound and both finished good outbound. So companies are doing that. What's different is we've applied Watson and AI to look for early disruptions so that we can proactively source other components from maybe completely different suppliers so that we can meet the customer's order on demand. And then we facilitate that we create a resolution room and we pull in the 2, 3, 4 people from across our supply chain that can quickly resolve it and then provide them the data. So that the key is getting the data to the right people at the right time so they can make the right decisions and keep things moving.
No, that's very helpful. I want to just give you a quick rundown of what we are seeing in the marketplace, having followed some of the companies all of you have mentioned, including IBM. Being open is very important. It's not just always about public cloud. It is, on-premise systems are extremely important, and modernization of that, I think, is going to be probably the next biggest, IT spend that we are going to see in the future. We do expect a massive change in the way ERP software is implemented, but perhaps not till next year. In the near term, we are looking at, other software areas that are being accepted more. But, this, to me, I learned a fair amount about how some of you are thinking about where you're going to take your respective companies in the future. For us, it's not just one particular technology, but it's a confluence of a lot of these areas from, hybrid cloud, private cloud, 5G, and then, edge computing that is going to make a huge difference in the way we operate. And not to mention sustainability, as Anne brought it up. So from that point, it's a very exciting time for all of us in this arena. And one of the things I believe is, Nicole will send a key takeaways article once it's complete. And we do thank our sponsor IBM for this particular event. With that, it was a pleasure talking to everybody. Ciao.